Hello. This is the brightest audience and also the brightest room I've ever spoken in. It's great because I can see all the faces. Hello, come in, have a seat. Thank you for bringing me to Warsaw because I've never been to Warsaw before. I've only been to Krakow, but I hear Warsaw is cooler, right? So it's pretty cool that actually. Oh, okay, good. It's pretty cool because I was only planning to go to Krakow, and then the RUC meetup popped up one day later, and those guys brought me here, which is amazing. So I'll be here for 2 nights and 3 days, including today. So we have lots of things to do. You have to show me the city, the bars, museums of beer and vodka, and this kind of stuff. So the original talk title is Trailblazer 2.1. I decided, since I do not know the audience that well, because I've never been to Warsaw, who knows if people know Trailblazer or not, so I'll have some introduction about what is Trailblazer, then I'll talk about 2.1 in specific. Because 2.1 has a massive, actually you can't see all of the slides, which is fine because whatever. So yesterday I had 45 minutes to fill, so I had lots of introduction and like blah blah blah, and this is how. So I was basically talking about how Trailblazer became Trailblazer. There's people, they want to come in, but they are too shy. Hey, welcome. So yesterday I was showing a couple of gems I've written in the past years before I made Trailblazer a thing. I was talking about like cells and reform and representable and a few gems. So the point of this introduction was, because I can't give this introduction today, that all the gems had the same pattern, which is basically encapsulation. So instead of having one massive like model or model function or model method or massive controller, you had like small classes that help you to implement one thing. For example, rendering something or parsing something or validating something. So you had like one object for each task, and that is kind of the job of all the gems I've invented in the last years. And so this philosophy kind of shaped the way I wrote software, because I found it kind of easier to write small objects and do small things instead of having one massive object, the way our bright leader DHH tells us to write software. So I prefer smaller objects, small responsibility scopes, and this gives me a more stable software architecture. Yep. Yesterday I also had a DHH rant. I removed it from this talk because it was on video, is on video, right? So people can see it, and I don't want to be hated. Okay, so Trailblazer is nothing new. It was first appeared like, I don't know, like 3 or 4 years ago. It started with version 1 point something, because semantic versioning, you know, right, Piotr? So the idea of Trailblazer from the beginning was what I just was saying, you know, the small object. So the main change to the Rails, so Trailblazer works on top of Rails or on top of Sinatra or something. And the main idea was we introduced something we called operations. So instead of having business code in models and in controllers and somewhere else and service object, we introduced this operation. So basically controllers would be really slim, yeah? They would do HTTP specific stuff, then call the operation, let the operation handle all the necessary logic for business, and then render the results. So in the ideal world, a controller in Trailblazer 1 or Trailblazer 2 really just calls an operation, passes in all the data it's needed, and handles the rendering of the result. You know, this could be JSON rendering, this could be an HTML page or AJAX request or whatever. So Trailblazer, the operation, is not coupled to HTTP. Yeah? HTTP happens in the controller. And it really boils down to this service object, as some people call it. So an operation is really just a class you call, and it does a lot of stuff, and it orchestrates to different other objects to accomplish that job, and you only get back a result. So there's no way to interfere with what happens in the operation, and the operation has no idea what happens on the outside. Yeah, so that's something I learned from all the other gems I worked on, because it proves to be very, very versatile. And of course, some people like new stuff, some people don't like new stuff. So one of the main arguments against Trailblazer was like, oh, no, you're just moving all the logic from the controller to another God object, and everything is implemented in an object now instead of in the controller. So that's nothing, like, this is still the same mistake, because you still have a lot of code. And I mean, if you write applications, you need code, yeah? So there has to be code somewhere, because otherwise your application is going to do nothing. I like the idea of that application, but my clients don't. So. So the operation is basically not a God object, it is an object that orchestrates to other objects or to other functions or whatever, you know. So an operation handles different other objects and tells them, delegates them, tells them do this, do that. So that's kind of to prove that we absolutely do not have a God object here, but an orchestrator. And in Trailblazer 1.1, you can see, you derive from Trailblazer operation, and then you had lots of DSL stuff, and you could configure. So you don't have to understand all this code. So what I'm trying to show is you had a lot of DSL to define a validation. You know, we called it a contract, or still call it contract. You could define, create a comment model for me automatically, and then you had this process method where you could run your own code, so to speak. So. Besides all this DSL stuff, the meat was basically happening in the process method. So you would get the params, or whatever you pass into the operation call, you would get that as an argument, and then you could, instantiate models and run contracts and run, after save callbacks, after save code. Because in Trailblazer, ideally, the model is empty and only does associations and finders. So no callbacks, no validations in the model. This all happens in the Trailblazer, in the operations, yeah? So the process method was a mistake in 1.1, because this method now started to grow, which was the main argument from people against Trailblazer, saying, you just moved all the code into the process method. And you put some fancy DSL on top, and now we don't know what's going on. And you know what? Those people were right. What was cool about this approach? Actually, it's great to speak now, because yesterday I spoke 2 hours later and I was really drunk. It was really hard to formulate what I want to say. So the cool thing about the operation, even though the process method was not cool, the great thing was that you could test operations super easy in a unit test without any HTTP, rack test, blah, blah, blah. You can just call the operation, you get the result object. It does exactly the same it does in a controller in a unit test. And then you can run your expects or your mini test or whatever and check, did this operation do what I want? And what was even cooler is that you can use operations as factories. So you don't have to have factory girl repeating the code to set up some application state for a test. You just use a chain of operations, or just one operation, to create objects for your test. Because if I want to have a comment to update, I have to create a comment. Instead of running factory girl, that does almost the correct thing, but you might have forgotten one specific flag or something. In Trailblazer, you run the operation and you have the exact same application state for your test that you have in production. So people really started to understand the idea of encapsulation when they saw how we test and how we use operations as a factory. For some people, this might be super boring and okay, a service object, great, but a lot of people didn't even think that far, because in Rails everything is the controller and the model and integration tests, and who needs testing anyway, and whatever. Let's don't rant today, let's be all friends. So the main problem in 1.1 was really that process method mixed with DSL, you could, for example, configure a policy that is run automatically before the process method, so the policy would test, are we allowed to run the rest of the code? So it was really hard to understand. So you always had to look at the call stack, when is the policy run? When is my code run? What else is run? How can I hook into that call stack? So you had to know the implementation of the operation internals, which is wrong in my opinion. And I really hated it. The problem was that lots of people started using Trailblazer 1 point something instantly, so I didn't have a chance to even like fix it and make it better, because once you have this call stack implemented, people will use it, and people will override build model, for example, Gesundheit. And so if you rename build model in the next version, they will say, hey, what happened? My code is not run anymore. So that's the problem with premature versioning. I need a drink. By the way, someone said there's free drinks for all of us. Why is no one having a beer? That's the idea of free drinks is to make the audience complying. But yeah, you've been doing this for 8 years, right? Yeah. Okay, so what I kind of learned in Trailblazer 1.1 is that using Ruby as Ruby is sometimes maybe cool, but in this case it was wrong. So I was really trying to, I actually thought I can somehow achieve a really extendable framework by like nesting method calls. And at some point I realized this is not like the way I want to keep going with this project. Because if someone doesn't want to run a policy, but someone wants to run the policy maybe after the process method, or if someone wants to run 2 policies, or if someone wants to, I don't know, validate a contract before the policy is called, they have a problem. They have to know all the internals about the object. And the problem is that this is basically Ruby-esque, and so people do that and think it's right, me included. I'm going to talk about the solution soon. One other thing, why is there my cursor in the slides? So one other thing which was kind of like a game changer. You prefer standing, that's cool. Me too. One other thing we had that was kind of like mind-changing was that we had a new file structure. So instead of ordering files by technology, we ordered them by concepts and then by technology. Yeah, so like kind of the inverse thing as in Rails. In Rails, you have like app controller model, app controller comment, app controller what else, and here we have app concept, and then you have the name of the actual domain object, and then you have the different technology layers in that folder. So it's a more componentized approach, and this concepts directory was optional in your Rails stack, so you could still have models and controllers and service objects and whatever you want in the old style, but in app concepts you had this new Trailblazer style, so that kind of empowered people to use Trailblazer in existing applications. But we had this problem with the process method, so that really freaked me out. And I realized, okay, maybe it's time to leave object-oriented programming, and I was actually a little bit inspired by our beautiful Piotr Solnitsa, first row on the left-hand side, to switch to some other thinking, which is functional programming. Yeah, because what I wanted to have is a chain of logic run, yeah, in an arbitrary order and resortable and reformable, whatever. And that didn't work with the Ruby approach of nesting methods. And I found this railway-oriented programming idea on the net. You can guess who inspired me to look into that. And so the idea of railway programming is that you have 2 tracks. On the one side, you have like the normal logic, and on the other side, you have the like arrow track that if something goes wrong and one on the like positive side, it will jump to the arrow track and skip the rest of the steps on the success path. And I was really intrigued by that idea, and I started to work on this, and it was actually really simple. So we quickly had a new DSL, which kind of allows you to define a railway, actually an extended railway, using pure Ruby, and then you had your little steps. And Trailblazer, the operation, g'day, would make sure that everything is executed in the order you're expecting it to be executed. So we still had the same public interface. So this is Trailblazer 2.0. So you would call the class, and you pass in dependencies, and you would get back a result object. And you could ask the result object, were you successful? That means it was ending on the upper track. Or were you not successful? Then it would mean it was ending on the lower track. Inspired by the dry RB result object API. I wanted to be compatible. because I like to be compatible. I think I'm a compatible person in general. And so the result object would also be responsible to communicate data to the outside. So everything you want to kind of tell the caller of the operation had to be written to the context object, and then you can read that from the result object, which is one and the same object, by the way. I'm going to show you how to do that in a second. Yeah, so the API, super simple. You call that thing, you can say, hey, you were successful or not, and you can ask it for additional data. And now you might be wondering how. I mean, this is great, the railway and everything, but how do I implement the actual logic? Yeah, how do I implement the boxes in the diagram? And that basically was the most common pattern was to define instance methods in the operation itself. And the operation, the instance method has the same name as the DSL argument, and it will receive a context object and keyword arguments. And here you can see how I write something to the context object. So the context object, I can see people looking and like making sure they understand it. That's awesome. It's because it's early and no one is drunk. So you write stuff you can write anything you want to the context object, and that is exactly what you can read from the result object in the end, yeah? And in those step methods, you can do anything you want. You can run, I don't know, a Redis query, write to active record, run a reform, form object validation, run a dry schema, whatever you want. Like, this is up to you. But the idea was to give people a really simple way to structure their code without them having to think how to orchestrate it, yeah? And we also had some really cool usage of keyword arguments, the only useful feature introduced in Ruby since 1.9. Sorry. Instead of having to, go through the context object to access data, you could just say, I want to have, for example, the params keyword, and then it would automatically pick that from the context object and gave it that data in a local variable. So whatever, it was just a good way to shortcut some code. You could also have callable objects as step implementations. Yeah? So instead of having an instance method, I could just give it a constant, and then the constant has a call method, or the constant has to be a callable object. That can be a lambda, that can be an object instance, that can be a class, and the call method has the exact same signature as the steps we saw earlier. So there's different ways to write code, yeah, to write steps. So you're not limited to instance methods. And the last really crucial thing that made it very useful is that we had a way to nest operations. You could compose big trees of code, business code, by using nesting. So here I have, I have some 2 local steps, and then I run the operation comment save to Redis, for example. Yeah, so if you look at this, this is the diagram, and it's very complicated, which is why I simplified it. So here's my save to Redis operation, and you see it's an operation itself. So it has 2 different outcomes, and I run this operation after the validate step, and then I wire the 2 outputs to my existing outer operation. So this looks a bit confusing on purpose, but the DSL made it really simple, and people use it all across their applications. But they said, okay, cool, now we have this structuring, we have nesting, we have this context object, which is the only mutable object. That's pretty cool, but it still sucks, because open source always sucks. Like, it doesn't matter what you do, it always sucks because something is missing you didn't think of, and they're like, oh, sorry, yeah. And so what they wanted, for example, was to have a more than 2 tracks, you can arrow out early, and they got this with a new option, and they also wanted to have something to find out which path did my operation take. So did it go this way? Did it go that way? Did it go that way? Did it go that way? So we call it tracing. So that was also something I really wanted, but with the implementation in 2.0, it was kind of hard to achieve that. So again, I wanted to be functional, and I didn't want to say, okay, if you want tracing like this, let's change the operation at runtime or something. So I had to think, again, everything I wrote is kind of bullshit. Let's re-implement all the internals again for 2.1. And then people said, hey, you keep changing. So this is actually a photo where I'm discussing. So this guy asked me, he literally said, why did you, asshole, change the API again? So all I wanted all I wanted, yeah, is, like I said, I'm a compatible person. So all I wanted was to make programmers' lives easier, yeah, by introducing patterns that are kind of useful. And then all you get is like, why did you change the API? I want to program in 1.1 style, even though it sucks. So yeah, whatever. So this is what open source developers are confronted with almost every day. It's not that bad. I don't know what this is. It's a line, horizontal.
It was so simple. That was the original Rails approach.
The railway, single railway pattern, yeah, it's pretty decent, I would say. Okay, so I decided like 1 year ago, I decided, okay, let's rewrite all the internals again because it's so much fun and you get so much positive feedback, hashtag not. So I started working on Trailblazer 2.1. There's so many dark slides. It's like my soul. So the first thing I wanted, or people wanted, was they wanted to have like, instead of this railway, they wanted to have like additional connections, or they wanted to be able to jump to like new ends, or like suspend and resume, or go back in the railway. So, hey, good evening. You missed half of the talk. So they wanted to have new mechanics to build more different flows. And at the same time, I started working for the German police. I'm not a policeman, and I don't like the police, but it's a cool job because they use Trailblazer. And my job was to kind of, this is like a secret document I took from them, and I put some black here so it looks like super official and exclusive. So what they had lots of diagrams this way, and they had lots of Ruby code, and the Ruby code and the diagrams had no correlation anymore. So they were supposed to, like the Ruby code was supposed to work like the diagrams, and the diagrams were supposed to describe the Ruby code. And so I saw the diagrams, I saw Ruby code, I knew what I wanted to do in Trailblazer 2.1, and this is where I kind of discovered BPMN. This is the business process modeling notation. It's from Java. It's a terrible thing because it's from Java. And this is also the point where I started wearing suits every day to work just to look like an enterprise developer with my certificate on the wall. So I started to dive into BPMN because this is exactly it's a diagram language that basically describes exactly what I wanted to do with Trailblazer 2.1 and what the police wanted to describe their processes, because it is a language to describe business processes. So I found it super interesting from day one, but people said, what the fuck's wrong with you? Since when are we doing enterprise in Ruby? Since when do we use Java stuff? Like, you're going the wrong way. Stuff in Java is a little bit like when you discover a new music style. And just because you love heavy metal or punk rock doesn't mean you can't look into something like jazz and find out, hey, actually jazz is a kind of cool thing, even though only old people listen to it. I hope I'm not offending anyone. There's no old people here. So BPMN is a diagram language. It's great. You have like brr, lots of things. Basically, all you have is boxes, circles, arrows, and vomiting unicorns. No, you don't have them. So that's BPMN in a nutshell. You also have pools where you can kind of structure flows and make it more visible to the modeler, as we call them, to show where what happens, but pools are not really relevant here. You have functions, so you can have, if you put a plus in one of those boxes, it means this is another extended activity, so everything with arrows and boxes is an activity, so you can kind of nest activities. You see, this is exactly like what we do in Trailblazer. So it's basically like reusing components in components. You have something called end events, so every activity has to end in some circle. The first person is falling asleep. It's early, it's only 7 or something. You can rewire, so nested activities have their end events, and you can wire those end events to other activities, again, outside. It's really cool, like it's just super simple to model complex flows. And then they have one concept I was struggling a little bit with is events. So you can throw events to kind of notify the system, hey, something here happened. And you can catch events. That's the one without the black. So basically getting activated when a certain event was thrown. Yeah, so, but don't worry about this. It's super simple. And that's basically BPMN in a nutshell. So it's not like, I mean, I could read 582 pages of the specification, or I can read 10 pages and kind of start working with it. I try to use, as always, one of the dry RB gem suite gems, which is dry transaction. The problem with dry transaction was at that point that it was really hard to model like non-linear flows, because people wanted to go back in their activities, and people wanted to nest activities and all this kind of stuff. I didn't really manage to get that done with dry transaction, which is why we started working on the activity gem. So an activity is since Trailblazer 2.1. And it's basically like an operation, but it's usually done as a module. And then you extend the strategy into that module. So here I want to have a railway. There's different strategies like linear paths and workflows and all this kind of stuff. Not really relevant. But then you have the same idea. Like you have methods, class methods in this case, and then you use the API or the DSL you already know, like step and all this kind of stuff to model your boxes and connect the boxes to other boxes. So it's basically like an operation, only a little bit simpler. So what we just saw, yeah, you know, step method blah, will basically give you a really simple linear flow, just as an example. So what we instantly added was something like you can branch out of boxes manually. Yeah, this worked by, so don't try to understand every little detail here. This is just an example of the DSL and that it is not super complicated. So for example, I can say, hey, my ID present box should have an output failure that goes to its own end, which is called ID missing, you know, this kind of stuff. So if you look at the diagram, it's super simple to understand. And we also had have like additional features, like you can build your own separate path, for example, using this path method and blah, blah, blah. You have so we have great new documentation, by the way, because I'm striving to be the open source project with the best documentation in the world. It's really hard. Lots of competition, but not with dry. Just kidding. So yesterday was DHH, today is Piotr. So we also have really cool support for nesting in 2.1. So you see there's a nested operation with lots of different ends, and you want to wire those ends to different connections. And this basically also works with the output DSL thing, and then you can just wire them and blah, blah, blah. So you saw the diagram, and it should be kind of clear how it works. So what I'm trying to say is it's super simple to build really complex flows without any, like you don't have to be a master of mathematical graph theory or something like that. You can also push your operations or activities via the developer gem to our editor, and it will render the activity graphically for you. This is a paid product, so you have to sign up for it and pay after 4 weeks, and it will render beautiful diagrams. This diagram has nothing to do with the code I was showing, it's just an example. Written by our beautiful friend Nicolas Barreras from Uruguay. So now I'm going to ask you, he told me mate, you know, the stuff he's drinking, is a thing in Poland, but it's not, right? It is? You're saying yes, because in Krakow everyone said no. But people in Krakow don't have taste, right? Okay, so the kind of my new baby in Trailblazer is the workflow gem, which basically allows you to model massive workflows that have, you know, they might stop, suspend, resume over many requests, and it basically allows you to model real applications using BPMN, but you still work with activity mechanics, yeah, from the gems we just saw. So this is an example from the police for a one-time password login, yeah, so a user is created, and the user logs in with a one-time password, then the password is checked. If it's wrong, the user has to sign in again. If it's right, the user has to change their password. They have to. There's no way they can skip this state, and so on and so on. And the password has to be like matching they have like password and confirm password, and they have to match and all this kind of stuff. So implementing stuff of this in like Rails way is kind of a, I don't want to say nightmare, but it's really really hard. With the workflow thinking in Trailblazer 2.1, you literally draw diagrams or write them using the Ruby DSL, and we use, so at the police we use, this is a joke, like we have massive workflows and they actually describe what is happening in the project, and the Ruby code describes those diagrams. So it's exactly what I was hired for, and it only took me 1 year. So this is an example how you could write such a workflow in Ruby without having to use the editor. So you can see it's the same DSL in a way. So You can do everything in Ruby if you want, you don't need the editor. Just to give you an example, every box you just saw on that diagram is again follows the same API, context object, so call method, context object, keyword arguments. It's the same idea again as we had in operations and in activities. So every box is just a callable object, okay? So and it can be an operation again, there can be an activity, there can be your custom code. So it's all the same idea. Just a really quick example how the suspend and resume works. So, you know, like you set up a user, then you send this user an OTP, like a one-time password, and so the user logs in, tries to like enter the OTP, then the OTP gets checked, then if it's okay, the user has to change their password. So that's a process that takes several requests, right? So you have to, like this, there needs to be some mechanism for resume and suspend, and that's exactly what we built. So basically, every time we hit such a circle thing, the Trailblazer will stop and suspend the process and allow you to resume it by throwing a certain event. So here's an example. Like I start this whole workflow by triggering events. That's how the API works. Yeah, to start this event, this workflow, I create a start event. This is pseudocode because this is all API that doesn't exist yet. I mean, it exists, but it's secret because it's for the police. So you create a start event, you trigger that start event, and that will basically run this event, trigger this event, run the first box, or as many boxes as it hits, and once it hits a suspend event, it will stop here, yeah? So that's why there's leaves, because it's like old, and you know, like vineyard and graveyard, and that's where you stop. So what happens when you trigger an event and you run the workflow is that it will return you the next event to resume that workflow. Yeah, so an event has an ID and like lots of session data, and it's up to you what you put into the session. So like there's no magic happening. Trailblazer doesn't figure out, do you want to save this and that? It's all up to you. But structurally, you always get an event to resume the next process. And Trailblazer allows you to kind of persist events so you can recall them in a later request. Yeah, to start from here again, all I have to do is I grab this event with this specific ID that we got, and I trigger the process engine with that event, and it will continue from here, go here, and stop in the next suspend event. So that's basically the mechanics of how to build complex workflows with a non-persistent environment, because Ruby is built on like process, request, request, request. Yeah, and it works amazingly well. There's different strategies for session management, and you don't have to use Trailblazer for this persisting and all this kind of stuff. But I mean, structurally, you have a lot of power now because you can model long-running processes and not just one request. Yeah, so this is an example for a one-time password setup, but we have massive workflows that like hunt criminals, hunt them down, kill them, kill their families, kill everyone who knows their families, and return to the suspend event. Hey, no, this is like police is peaceful, okay? Okay, so also another feature that we have in 2.1 now is that what people are asking for is the tracing. So you can just say, hey, process engine, activate your tracing and run the process. And it will give you some weird data object that basically shows you, oh no, something happened. I think here we go. So what was that? It wasn't me. I'm not drunk yet. So the tracing will basically show you exactly what happened in the last request or in the last 500 requests, show you exactly what path you took, what data came in, what data came out of each step. So it's super simple to track down bugs and to make sure that your software is actually doing what it's supposed to be. So the tracing is an inevitable feature that I use every day because I write so many bugs that I need to find out what happened. And it's much more advanced, of course, than just using pry or something. You can use pry if you want. So this is all kind of finished and out. There's no critics at all. Like everything is perfect. No one's complaining. Everyone wants to pay for it. It's like paradise. One cool thing that is coming up in Trailblazer 2.2 is that we add some kind of typing. So every step, every box in the diagram can have define its return types and also its incoming types. So we kind of have like a typing in a way, and you can catch errors way faster than the Ruby way where it just says undefined method or nil. So that's a cool new feature. I'm really excited to work on it. But generally, this is Trailblazer 1, then Trailblazer 2, and then Trailblazer 2.1. I hope you had some kind of insight in the development process and where this is going. You can see it's not Ruby like we did Ruby in the 90s. It's very different, but it's super helpful to build. When did you start? Because your Twitter biography says you were a nerd before it was cool or something like that. It's time to hit the bar. So, if I have if I can give you a recommendation, check it out. If you build complex applications with workflows and stuff, this is a good thing to start with. You don't have to love it, but you should. And if you have questions, I'm on Twitter, Skype, Facebook. What else? Here, I'm here. I'm here. You can just come and ask me. And thank you so much for your attention. Great audience.